So this identity, the identity means this one, the equal sign. We need to prove this side equal to that side. So our job is to select one side to start. We learned that we cannot start or simplify both sides of the equal sign. I cannot simplify this and simplify this to get 1 equal to 1. This is out. This is not correct. At the beginning, for solving question like this, we need to say we're going to start from left. We do algebra, go to right, or we're going to say we start from right. We're going to go to the left. In exam, you might have like a 2 question like this. So you have to take your time. Is this left to right or right to left? Usually we select the side that has more content in it. There's like something that we can simplify. I mean, this left side, we are able to do something to get to the other side. I mean, from the right-hand side, sine square is difficult to expand it to get to that part. So left will be the good pick here. So I'm gonna start with the left, and we're gonna simplify without any mistake, without thinking, because one algebraic mistake, this both gonna get a hole, and then you sink. You're never gonna go to other side of equal sign. Good. So I'm gonna write secant square theta minus 1 divided by secant square theta equal to. Then I can refer to the page of notes, this one. This is all the identity that we have. Right here. All right, Karen?
Yeah.
Nicole. So, John Marocco. So the level, I mean, somehow I want to tell you guys that I feel you guys, when you see a question like this, you freak out. But with having a page of note with all the formula is simple. You just need to don't freak out and don't do any mistake. So which one should, we know the other side, our home will be just sine square. We have to get to sine. So here we have only secant. Let's see what is secant. We have secant is 1 over sine. So that's great. Oh, that's cosecant. Sorry. Secant is 1 over cosine. So instead of secant, I can plug 1 over cosine. I know if I change it, I get everything in terms of cosine, but that's a good, that's a good start, because then we have something in terms of sine and cosine. We have another formula here. So let's do that. So instead of secant, I'm going to put 1 over cosine. So we're going to have 1 over cosine of theta. Because it's a square, I add a square here. Minus 1 over cosine squared theta. All right. So far, this didn't do anything wrong. So instead of secant, followed by this note, I put 1 over cosine. Equal to. So this is a line that we have here, fraction. We need to simplify the top and the bottom denominator. Good. The denominator is 1 over cosine squared, so I'm just going to leave 1 over cosine squared. But the top one, we can find the common denominator, correct? It will be cosine squared theta with 1 minus cosine squared theta. So I multiply this by cosine squared theta, multiply this by cosine squared theta. So that's what I get. Equal to this cosine squared and that cosine squared theta, they cancel by dividing. So therefore, we have only 1 minus cosine square of theta. So we end up having this. Is this equal to that? So we need to get to sine square. How do we show that that part equal to this part? Anytime we have cosine, and we're going to make it to sine, if we have sine, make it to cosine, there is a formula. The first formula that we learn, sine squared, we learn sine squared theta plus cosine squared theta equal to 1. We proved it with Pythagorean theorem. From here, from this one, if you solve for sine, if I keep this sine square one side, I will have 1 minus cosine squared theta. If I subtract cosine squared, I see 1 minus cosine squared equal to sine squared. So instead of 1 minus cosine squared, I can put sine squared theta. And we proved it, and we're done. At the end, you just need to put the box or the home that we are at home and cooking dinner. We're done. All right. You cannot say this is too difficult. No, this is fun. And you have only a couple of questions like this. And the good thing is all of them are similar. You need to know a few techniques. One of the technique was following this page of little bit of fundamental identity. Let's have another one. Little spicy. Okay. Another identity. Which is cosine squared of beta minus sine square of beta equal to 2 cosine square beta minus 1. So we need to prove this. We have to show it. Which side should we start? This is, should we go from left to right or from right to left? Which side?
Maybe the left side.
Same as last time? Left to right? Yeah, I mean, I would start with left because there's more things to do. But there's nothing wrong if you start from right and you want to go to left. Sometimes it's more algebra to do. But the point is you should not give up when you select that. Don't just keep changing around left to right, right to left. So there's nothing wrong if you want to start with other sides. I'm going to start with the left. Good. So what we do, we need to just observe what do we have. Well, it doesn't look good. We have to look at it until we get old to see should we start from, we're going to start with left. What should we do to the other side? We only should have cosine. That means algebraically, we need to get rid of sine. And we have this page, right? So let's look at it. We're dealing with only cosine and sine. So the only formula that we have is this guy. We know sine square theta plus cosine square theta equal to 1. From here, we have two more formulas. We just subtract is sine squared of theta. It will be 1 minus cosine square theta, or cosine square theta equal to 1 minus sine square theta. All right, from this guy. By subtracting 1 to other side, you get this. Since only we have cosine the other side, so instead of sine squared of beta, I can put 1 minus cosine squared. Good. So we have cosine squared of beta minus parenthesis. I put parenthesis because there's a negative here. I don't want to do any mistake. So instead of sine squared, I'm going to put 1. I'm going to put 1 minus cosine squared beta. Then we have equal sign. We have cosine squared beta minus 1 minus minus is plus cosine squared beta. I can just review that I didn't do anything wrong. Then I go back. We have cosine squared and cosine squared. This gives me 2 cosine squared beta minus 1. This is exactly same as what we have at home. So we proved it. Any question? So for the identity, you need to have practice. And there are only few questions on your homework and only a couple questions will you see in exam. But in order you do well, you need to know all the type of techniques. For example, the last 2 questions, we use this formula, okay? Sometimes we need to do some other formula. Let me make another one. Tangent to power of 5x equal to tangent cubed of x, the secant squared of x minus tangent cubed of x. So we need to prove this. I know when you look at this one, you like to cry. So what is this? How do we solve this one? But we don't look at the end of how to solve it. The first step is we need to decide, should we go from left or right?
Right side.
For sure, right? Let me ask. Nicole, what do you think? Nicole. Karen, what do you think?
I agree with Joshua.
You agree with Josh. It would be much easier to say right, but you know. Elizabeth, what do you think? Nutrition, we need nutrition. I have to be nice to Elizabeth.
Right side as well.
Correct. So definitely we start with the right hand side because again, there's more things to do to get to the right, to the left. So we're gonna start with the right. So what should we do? What algebra? What's the first thing we can do? Keep breaking my iPad. So we have page of note here, and this is looks like a dollar to us. There is no direct formula that from that there we don't see this directly on the page. So what should we do? Any suggestion?
They said tangent square theta plus 1 equals secant. Is it?
This one?
Yeah.
Very good. So instead of secant, yeah, this is a good formula to pick. So Karen said secant square theta equal to tangent square theta plus 1. What does it mean? So this is a formula that we don't negotiate where this coming from. We just love it. So do you want me substitute instead of this secant squared? Do you want me plug tangent squared plus 1? Yes, Karen?
Yeah.
Yeah, there's nothing wrong. Let's do it. So we're gonna start with the right. We have tangent cubed of x parenthesis minus tangent cubed of x. Here I'm going to say tangent squared theta plus 1 equal. Now the good thing is everything in terms of tangents. The other side is tangent as well. And we don't want to do any type of cheating here. Let's say, oh, this is equal to tangent to the power 5. No, you need to show your work. The way I'm showing it, I mean, I know this is equal, but you need to do all the steps that you are going to get to the other side. You don't want to jump, so this equals that. So now I multiply, I FOIL it. I will say tangent cubed times tangent squared. What do we get if I multiply? Jake, you look like a Robin Hood. What is tangent cubed times tangent squared?
Tangent to the 5th.
Very nice. Yeah, so the base are same. If you have a to power n times a to power m, a to power n plus m, the exponent rule. So we get tangent to power 5. This should be x, sorry guys. X, then tangent square times plus 1 will be plus tangent cube of x and minus tangent cube of x. Not tangent cube of x, tangent cube of x will cancel. What left is tangent to the power 5x. And this plus. So we proved it. We go to the home. So how simple is that? If you see super ugly formula, believe me, is nothing in it. Freak out if there's a small formula, small and simplified. Times it. Okay. Now we're going to learn some new formulas. I'm going to draw a unit circle. So this is a circle that we learn a lot in this semester. This is plus direction, that's negative direction. We start from 0, we go to pi half, which is 90 degrees, and this is pi 180, 3 pi half, and 2 pi. That's one revolution, right? If we go to the other side, it will be negative. We proved that if it is, what did I do? For example, when it's 30 degrees on the unit circle that you have, is that 30? This is 30 degrees. 30 degrees is pi over 6, same, correct? This point here is, we have, this is, I'm going to write pi over 6. You put in the degrees that you guys will like it more, 30 degrees, right? We know sine of 30 equal to 1/2. We have cosine of 30 equal to radical 3 over 2. So we proved this, correct? We went through all this algebra. Let's have another angle like 45. Let's say it's 45. This guy is 45 degrees. Then we learn sine of 45 degrees equal to radical 2 over 2, and cosine of 45 degrees equal to radical 2 over 2. Correct? We went through, maybe proved this with Pythagorean theorem. Now, if I ask you guys, what is sine of 15 degrees? How did we do this? Are we able to find it without using calculator? I know Elizabeth just look at the calculator right now. So 15 is nothing on the unit circle. Let me bring the unit circle as well. Do we have 15 degree here that you can just copy? No, correct? Are you guys having popcorn or just watching TV? Where are you guys? 15 is not there. Good?
Yes.
Very. So, and the question said, if they said sine of 15 exact, that means you cannot use the calculator. Calculator gives you all decimal. So there are set of formulas for sum of two angles or subtraction, the difference. So that means in order to get 15, 15 is 45 minus 30 degrees. I agree. With 15 degrees, I can put 45 minus 30 degrees. There would be a formula. Let me see if I can have that as well, image on my iPad. I had it from last year, if I can find it here. It's here. This beautiful set of formula. You have it on your note sheets, and you can. So, which formula are we going to use? This is 15 degree, correct? 15 is 45 minus 30. There's a formula here. Sine of A minus B equal to sine of A multiplied by cosine of B minus cosine of A times sine of B. I prove, this, there's a proof for this. We use distance formula, but I'm not going to prove it for you guys. You got to get confused, but I have it in one of my YouTube things. I proved one of them. And the proof is very interesting as well. But your job is to know that there is a formula, sum and difference. The first thing, I ask you a sine of 15. You say, oh, bummer, 15 is not on the unit circle. Then you go through this page of notes here. Are you able to get 15 degrees from adding and subtracting those 15, 30, no, not 15. We have 30, 45, 60, and 90. Are we able to get 15 degrees from one of them, two of them? You say, oh, yes, 15 come from 45 and 30. So 45 minus 30 is this guy. So A gonna be 45, B gonna go 30. So if you use that formula, it will be sine of 45 degrees multiplied by cosine of 30 degrees minus sine of cosine minus cosine of 45 degrees sine of 30 degrees. Do you guys see that? I just went. Correct? So not bad, correct? You as a human, not a robot, we just saw 15 degrees, 45 minus 30. There's a formula for it. I pick the formula and I will see what is A, what is B. Then I substitute A and B, A and B. Now I'm gonna go to the unit circle that you have. Sine of 45 is radical 2 over 2 multiply. Cosine of 30 is radical 3 over 2 minus cosine of 45 is radical 2 over 2. Sine of 30 is 1/2. Is this beautiful? I'm not talking about this rows, for example. Oh, I messed it up. I think I messed it up. Which one is beautiful? Do you think the formula is beautiful or the rows is beautiful?
Formula.
Very good. The formula is beautiful. So we got here. So now, I mean, so far the level of difficulty. Well, you think my flower wasn't pretty? So, so far, you see the question, you pick the formula, you substitute it from the unit circle. The difficult part here is at the end, you need to simplify. Definitely, you cannot sell it like this. You need to simplify that. But the good thing is, I mean, all of them are similar. Similar, I mean, the algebra part, it will be similar. Here, we're gonna this one gives us radical 6/4 minus radical 2/4. Radical 2 times 1, 2 times 2 is 4. That's equal to radical 6 minus radical 2/4. This is the final answer. And if you use the calculator right now, I mean, this much work will be waste of work because they ask us to find the exact, not the estimate. So this will be the final answer. Any question?
Professor, why can't you simplify the numerator to like square root of 4?
Very good question, Elizabeth. So let's do a little algebra here. We had radical 6 minus radical 2/4. Elizabeth said, why this is, we cannot do radical 4. There is no formula for the radical that tells us if we have radical A plus radical B, we will get radical A plus B. Or if it's minus, we get minus. There doesn't exist something like this. It's not true. For example, radical 16 plus radical 9, this is not equal to radical 16 plus 9. Radical 16 is 4, radical 9 is 3, correct? 4 plus 3 is 7. The other side is 25, is 5. So definitely 5 is not equal to 7. So we are not allowed to simplify inside of the radical. However, if we had like 5 radical 2 minus get 2 radical 2, if it's something like this, or the plus, if it's something like this, we write the radical 2, we add this coefficient. So this is 7 radical 2. All right, Elizabeth? If we have...
That makes sense. I think I just forgot about
Very
the.
good. But that's
I
good
just
that
forgot
you're
about that.
asking. That's good. So if we have radical 6 multiplied by radical 2, yes, we can write 12 if it's multiplication. If we have radical 6 divided by radical 2, yes, we can write it radical 3. Division, we also can simplify inside. But addition and subtraction, not allowed. We don't want to do those small mistakes. So you're taking the exam at home, you know we're going to deal with exponents and radical simplification. So it would be good to have those page of note for radical and exponent as well. Any question? Just want to see what time. Or 9:17 after. Any question for me? So let's go back to that beautiful formula that you guys love. To let you guys know, there's new set of, there are a few of those. Any question? No question. You guys having a good Monday so far. I'm gonna ask you guys. What is tangent of 75 degree? And the question is find the exact. Somebody has so much fun over there. Whose microphone is on?
Sorry.
That's okay. So they ask us find tangent of 75. Okay. And then the first thing you do is say, oh, great, exact value means no calculator. And hopefully I have this question inside of a unit circle. You look at it. You look inside of this. At the beginning, you're happy. You say, oh, but 75 is not there. You will be a little upset. Because if I ask us what is tangent of 60 or tangent of 120, we see it and easy to find, right? But that's 75 degrees. 75 is not there. Your next step is you get rid of this unit circle. The next step is to go through the formula sheet. Now the question is, can we come up with 75 with this formula? Yeah, go ahead, please.
It's 45 degrees
Very
plus
nice.
30 degrees.
45 plus 30 degrees. Both of them, we know it very well from the unit circle. So our job is to just relax. And pick a formula which is related to tangent of 75. Which formula do we pick? Is I pick 1, 2, 3, 4, 5, or 6? Which formula do we pick?
The first one?
First one? 1? This one?
I think so.
Very okay. Is that talking about? Are they asking sine of 75?
Oh, never mind.
Tangent of
Yeah.
75? Which one? 5, right? This guy. So 75, we are dealing with addition. That means this is good, this is good, this is good. We have sine, cosine, tangent. We're dealing with 3 different animals. Which animals we are dealing with? Tangents. So we need to pick tangents. So if the formula for adding tangent is tangent of alpha plus tangent of b divided by that. So I'm going to write tangents of 45 plus 30 degrees. Agree? Now I'm going to just copy the formula. This equal to tangent of 45 plus tangent of 30 degrees, 1 minus tangent of 45 times tangent of 30. All right. When I used to go to school, we used to memorize this, but you guys, you don't need to memorize it. You just need to know what formula to use. And if you don't have this page with you in exam, I mean, I would be happy to provide the formula. All right, so we so far, we picked this one. Nothing is wrong. TAN 75 is 45 plus 30. We use this note. We got this. Now we go to the unit circle because we are dealing with 45, 30. We know it exact. What is tangent of 45?
One.
Very good. Tangent of 45 is 1. What is tangent of 30?
Radical 3/3.
Very good. What's happening? Radical 3/3. We have 1 multiplied by radical 3/3 equal to. So we are done. We get rid of all those trigonometries because we're dealing with algebra now. So there is a line, fraction. We need to simplify top and bottom. 1 plus root 3/3. This is 1/1. We find the common denominator 3 times 3. It will be 3 plus root 3 divided by 3. In the denominator, I'm going to multiply this by 3, multiply that by 3 to have the same denominator. Then we have 3 minus root 3/3. This 3 and that 3 will cancel. The answer will be 3 plus root 3 divided by 3 minus root 3. So now the question is that time to drink the wine or we still need to continue? Are we done?
Can the other threes cancel out?
Elizabeth, no. So you're asking very good. I mean, you're bringing up something that we are reviewing it. Very good. Are we able to cancel out? So you are, where's those kind of, you are asking me I want to leave the thing. Well, let's get rid of this. You have 3 plus root 3/3 minus root 3. You are in the level to decide, should we leave it like this or we are able to simplify? Somebody said, Elizabeth said, cancel this 3. We have plus. If we had, I mean, if you cancel the 3, this is same as if I have 1,538 divided by 32, I cancel the 3. Is that bad? So we did, I mean, I'm sure you're not gonna, you don't like this. So that doesn't make sense. So same here. Anytime we have adding and subtracting, we cannot simplify. If this was, if it was 3 multiplied, for example, by radical 5 over 3 multiplied by radical 7, if it was a multiplication, then yes, you could cancel it. Not for adding and subtracting. We don't do that. All right, so please don't do those mistakes in exam. It would be very painful because you know the new topic, but little algebra, yep. All right, Elizabeth? Yeah. So should we leave it like this or we able to simplify? Marokel, should I leave it like this? Is this a home?
You can leave it like that.
You leave it like this? Or this is a bridge to go home. So here's more step to do. So somebody said, I think, Edison, should we leave it or should we simplify? Oh, wow, time is up. So let's go home then. No, this is, we're not gonna leave it like this. You guys learned that we cannot have radical on the denominator. So we need to multiply by 3 plus root 3, 3 plus root 3 to irrationalize the radical. So denominator will be 3 minus root 3 times 3 plus root 3 and time 3 plus root 3 times 3 plus root 3. Denominator, when you FOIL it, you get 9 minus 3, which is 6. At the top, you're gonna have. We will work on this on Wednesday.